Today we'll be continuing with chapter 6 and we're going to be looking at law of sines. So I'd like for you to take a minute to try these warm-ups that I have, or this warm-up with a couple of problems that I have from section 6.4 to practice that, and then we'll get started. Okay, the first one is one where you want to use the inside part to build your triangle. So I'm going to use this to set it up. And so sine is opposite over hypotenuse. So my opposite side will be 5. And my hypotenuse is going to be 13. Use the Pythagorean theorem to find my missing side. So this is a 5, 12, 13 triangle that we're working with here. So then I find the tangent of theta. So tangent is opposite over adjacent. So the opposite is 5 and the adjacent is 12. And so that's going to be the value for tangent of theta. If I look down here at this one, I'm solving it. If you remember, this is one where we have our circle, but our restricted domain on this one was between 0 and 180. So we're only looking at the first two quadrants. So we're going to disregard this part of our graph. But for sine, we do have two that we have to find. So we'll take the inverse sine of both sides. Be sure your calculator's in degrees. If you didn't get the right answer, it very well could be because you're not in degrees. The calculator is going to give you the reference angle, and it's basically giving you the first quadrant angle. So to get the second quadrant angle, you're going to do 180 minus this reference angle, and you're going to get 123.6 for the second angle there. Okay, so starting with the law of sines, this is one of a good rule for being able to solve triangles that you should be familiar with. Okay, so I'm going to ask the question, when do we use these? We've talked a lot about SOHCAHTOA and the relationships for sine, cosine, and tangent using opposite, adjacent, and hypotenuse. But the question is, when do these work? And the answer to that is they only work for right triangles, which is nice because a lot of things we work with are right triangles. But there's also quite a few triangles that are not right triangles. So if you try to do sine as opposite over hypotenuse and it's not a right triangle, it's not going to work. Okay, that's not going to be a correct relationship there. So what we're going to be looking at today with law of sines is a way to deal with those situations that are not right triangles. Okay, so to use the law of sines, it does not have to be a right triangle. We can use this to solve different scenarios. And so today we're going to look at law of sines, and next class we'll look at law of cosines. Law of sines works in particular situations, and the first of which is when you're given angle, side angle. So when you see this ASA, that just means an angle, the side in between those two angles, and another angle. You're looking at a situation like this, angle, side, angle. Okay, so what I have here is a slide that kind of shows when we're going to use what. The first case here is angle, side, angle, where you have an angle, a side, and another angle. And you can also have angle, angle, side is going to work the same way, or side, angle, angle, whichever way you want to call that. Both of those, you're going to have one side and two angles, and you're going to use the law of sines in order to solve that. The second case is the one that I refer to as the bad case. It's called the ambiguous case. You turn the letters around. I think it'll help you to figure out which one I'm talking about and which one is going to be the more difficult case, and that's this ambiguous case. So when we have side angle, then which is two sides and an angle opposite one of those sides, then that's the case that's going to give us the most problems because it's going to be an ambiguous case. We'll talk about how to approach that ambiguous case as we go through the lesson today. These other two cases we're going to address with law of cosines in the next class. So the side angle side case and the side case are going to be the ones that we use law of cosine for. Okay, so what the law of sine says is that the sine of angle A over side A, that ratio is equal to the ratio of sine of B over side B, and also sine of C over side C. So what's going to happen is when we're using this relationship here, you're going to use any two of the three. So I might have A and B, I might have B and C, I might have A and C, but it's going to be some relationship between two of the three sides there and angles. Okay, so just to make sure we're labeling everything correctly, just remember that side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. Lowercase letters denote sides, capital letters denote angles. Okay, so we have this example here. Solve the triangle using the law of sines. Assume that side C is 75, so we have 75 here. Angle A is 52 degrees. Angle B is 25 degrees. So we have angle, side, and angle that's provided to us. And that's one of the cases that uses law of sine. In order to use law of sines, you have to know all the parts for one of the letters. Okay, so you either have to know the capital and lowercase a, the capital and lowercase b, or the capital and lowercase c in order for you to be able to use law of sines. If you don't know at least one of the letters, both the capital and lowercase, then you're not going to be able to use law of sines. And you're probably saying, well, we don't have that here because we have something for C, something for A, and something for B. We can actually very quickly find angle C. We know that the sum of the angles of a triangle is 180 degrees. So if I subtract away the two angles that we already have, what we're going to get from that is the third angle. So if I subtract these, that's going to give me 103. Okay, so this is 103. So you can see that I have now angle C and side C. So that's what makes this a candidate for using law of sines. I'm going to advance here where I have a little bit more room to work. And so we already said this was 75. Angle A was 52. Angle B was 25. And we found angle C to be 103. So I'm going to go ahead and write that in here. I would suggest making a chart similar to what I have here just because it helps you keep organized with what you found and what you still need to find. Okay, so we're ready to go for side A and side B. So I'm going to use law of sine to do that. Since I have both pieces for angle for C, I'm going to make sure that I incorporate that into the setup that I'm using. So I'm going to do A and C first of all. So I'll do sine of A over A equals the sine of C over C. So that will be the sine of 52 degrees over side A equals the sine of 103 degrees over 75. So we want to plug in everything we know and then solve for what we don't know. So we're going to cross multiply. So if I cross multiply this way, I'm going to have 75 times the sine of 52. Here I'm going to have A times the sine of 103. I would recommend continuing to write it like this instead of going ahead and putting decimal answers in for these. That way you maintain your accuracy. If we need to solve for A, I'm going to divide away this sine of 103. Okay, so these will cancel. A is going to be, so at this point I'm going to put all this in the calculator. Be sure you're in degree mode. When I put all of that in the calculator, I'm going to get 60.66. Okay, and so we're rounding to the nearest tenth for the degrees and 2 decimal places for the length. So I'm going to leave this at 60.66. Okay, if I want to find side B, so this was finding side A. If I want to find side B, which I do need to do, I need to make sure that I use the letter that has the B in it. And now that I have A and C complete, I could pick one of those. I have more confidence in C just because that was an easier answer to get. So I'm going to keep using C. So I'm going to say the sine of B over B equals the sine of C over C. If I substitute in here, that's going to be the sine of 25 degrees over B equals the sine of 103 degrees over 75. This is the point that I'll cross multiply So I have 75. These are fairly long problems, so give yourself plenty of room. So 75 times the sine of 25 equals b times the sine of 103. We'll divide away this sine of 103. Remember that this is 1 unit here, so I can't split this apart. I've got to take it all together. Okay, so this is going to cancel. So b is going to be, and this is where I'll put this answer here in my calculator to get the number answer for it. And when I put that in the calculator, I should get 32.53 approximately. Okay. All right, so this is the case where we have the angle, the side, and the angle. It's an easy case because we only get one set of solutions and we don't have to worry about the second triangle or no triangle or one triangle. It's going to be just one triangle and it's going to be fairly simple to calculate. Okay, so moving on to our ambiguous case. This is the one that always gives us the hardest time. It's not difficult. You just have to understand and be mindful of what might happen. Okay, so we did the case of angle, side angle. Side angle, angle would work the same way. We get one unique triangle that's formed, and we found that triangle. But when we have this case here, the side, side angle, we could either have two triangles, one triangle, or no triangle. And that's why we call it this ambiguous case, because we really don't know until we get into the problem which one it's going to be. So here's kind of a sketch. In this first triangle, you can see that if you're given the angle, the side, and the side, or the side, side, and angle, what happens is it may be a case where this side is not long enough to actually make a triangle form. So this will be the no triangle case. It might be that it forms in such a way to make a right triangle. That's a possibility. Or it might make two triangles, okay? Because we can see here that this side, it can kind of either swing out or swing in. And in that case, we might have this kind of skinny little triangle here, or we may have the bigger triangle. And we don't really know. So this would be like a two triangle case. And then this would be another one where you could potentially have just one single triangle that's formed. So we have to just kind of approach it knowing that it might be no triangle, it might be one triangle, or it might be as many as two triangles. Okay, so if we're given this triangle here, we've got side, let's see, this would be side A is 7 on the square root of 2, side B is 7, and angle A is 45 degrees. So what we have is we have side, side, angle. So we know that side, side, angle is the ambiguous case, so we need to be mindful that there might be a second triangle that needs to be formed. Okay, so for on this one, if I look here, I have both pieces for the A's, so I'm definitely going to use that. And that also tells me because I have both pieces for the A's, the law of sine is a good candidate for doing this problem. So I can't really jump to doing the C's without first doing the B's. So let's go ahead and get the B's here. So I'm going to have sine of A over A equals the sine of B over B. Okay, angle A is 45 degrees, so I'm going to have the sine of 45 degrees over side A, which is 7 on the square root of 2. We don't know the B, and then the side B is 7. Okay, I'm still going to cross multiply, so when I do that, I'll have 7 times the sine of 45 degrees, and then I'm going to have 7 on the square root of 2 times the sine of B. Okay, I want to get b by itself, so I'm going to divide away this 7 on the square root of 2. So I have sine of b. My 7's would cancel, and I'm going to have the sine of 45 over the square root of 2. If you remember from your unit circle, if anytime these numbers show up that are on the unit circle, we want to take those values from it. So the sine of 45 is the square root of 2 over 2, and then we're going to divide that by the square root of 2. So that's going to be the square root of 2 over 2 times 1 over the square root of 2. So we end up with 1/2 when we simplify all of this. Okay, so we've got 1/2 is the sine of b. If we take the inverse sine of both sides, we get b equals the inverse sine of 1/2. If we think about this on the unit circle, we have the pi over 6 type angles, which are our 30-degree angles, have a sine that is 1/2. So that tells me that b is going to be 30. Okay, if you recall on in section 6.4, we talked about solving equations that looked like this, and the fact that when we're solving them and our domain is restricted to 0 to 180 degrees, then sine can potentially have two solutions to that. So the first solution we get by just doing inverse sine of 1/2, and you can either look on your unit circle or put that in your calculator, and you'll get 30 degrees. That's my first quadrant angle. But remember, we also could have a second quadrant angle. So when that happens, what we're going to do is we're going to do 180 minus the 30 degrees. So we're going to get 150. Okay. So my angle B could either be 30 degrees or it could be 150 degrees. I would suggest if you do see that a second triangle is necessary, make a second table for that second triangle. We'll look at one like that, but I want to show you why this one is only going to have one triangle. Okay, so if I want to find angle C, then angle C is going to be 180 minus the 45 minus the 30. Okay, so that's going to give me 105 degrees. So if angle B is 30, angle C is 105 degrees. But look what happens if angle B is 150. Okay, we run out of angles. There's not enough space in the triangle to have angles that are that add up to this much. This will be 195. So we've got way too much angle. So what that means is that we can't make a triangle out of this second case. So it's only going to be the 30 degrees that we have to worry about. Now we do still have to find side C for that, but it is only the 30-degree one that we have to do that for. So if I look here, I'm going to give myself a little bit of space to finish this up. Hopefully I can squeeze it in here. I'm going to just use the A's again. So I'll have sine of 45 over 7 on the square root of 2. And that's going to equal to the sine of 30 degrees divided, sorry, sine of 105 divided by side C. We'll cross multiply. Okay, we need to divide away this sine of 45. If everything's on the unit circle, then I would go ahead and fill these values in from the unit circle. Sine of 45 is on the unit circle, but the sine of 105 is not. So at this point, I would just go ahead and put this all in the calculator to get your answer out. That answer is going to be 13.52. So that's going to be the length of side C. Okay, so the rule that we see here is that if the sine of A is less than 1, then we're going to have to check that angle and its supplement as possibilities, okay? Because any angle smaller than 180 degrees can be in the triangle. So, so that's what we saw here, was that because the sine of A was less than 1, we needed to check and see if it was a one triangle situation or the two triangle situation. Okay, so looking more at the ambiguous case, this time for the possible two triangle case. So maybe this side swings out or maybe it swings in. We don't really know with the information we've been given. So we have to potentially solve for both triangles. So here we're given angle A, and side B. So here we have a case where we have been given angle A, we've been given side A, and we've been given side B. So this is the side angle case, and that's the one that we have to consider whether it has one triangle, two triangles, or no triangles that can be formed. So on this one, because this side can swing either in or out, well, then we need to check for the two triangle case. So what we're going to do is we're going to go ahead and get started here. I know that I could use law of sine because I have all the information for this letter A. So I'm going to use the sine of A over A equals the sine of B over B, since I have part of the information for letter B. So I have all my information for A, part of my information for B. So this is what I'm going to use here. So I'm going to do the sine of 43.1 degrees over 186.2. And that's going to equal the sine of angle B, which we don't know, divided by the 248.6, which is side B. Okay, we want to cross multiply. So when we do that, this is what we're going to have. I recommend that you don't go ahead and evaluate most of this until the very end so that you don't create more error in your answer. Okay, so I need to divide by the 186.2. So those will cancel. So I have the sine of B is going to be 248.6 times the sine of 43.1 degrees over 186.2. So to get rid of the sine, we need to do the inverse sine. So I'll do the inverse sine of all this. So if you really do get tired of copying it over throughout the problem, then you can go ahead and get a decimal answer for it all on the calculator. The only thing is just be sure you carry it quite a few decimal places in doing that. Okay, so when I put all of this in my calculator, what it's going to do is it's going to give me the answer, if I'm rounding it to one decimal place, of 65.8 degrees. Okay, so this is one of my angle B's. But because there's the potential for this second triangle, what I have to do is I have to consider the second quadrant angle as well. So back in the previous section, section 6.4, we looked at when we look at solving for sine of something, we have to consider both the first and the second quadrant angles when we're working with these triangles. So then what I'm going to do is I'm going to do 180 minus this 65.8. So 180 minus 65.8. If I subtract those, I'm going to get 114.2 degrees. So my angle B is either 65.8 or 114.2 degrees. Okay, so if you recall in the last example that we looked at, once we found these, we determined that it wasn't possible to make both triangles. Here, if we look at finding angle C, because that's what's going to tell us if we can make our triangles or not. So to find angle C, we're going to do 180 degrees, which is the total of the triangle, minus the one that we know, which was the 43.1. We're going to take away this first option for angle B, which is 65.8, and that's going to give us an angle that is 71.1 degrees. So that one would be fine. There's nothing wrong with that. So we would definitely a triangle would exist that would have these angles here. Okay, so let's look at seeing if we can use this 114.2. We're going to do the same thing. We're going to start with 180 degrees for the triangle. Subtract the 43.1 because that was this given angle. It's not changing. This time, instead of using the 65.8, we're going to use the 114.2 for our angle B. And when we do that, we end up with 22.7 degrees. Okay, and I put that in the wrong place. So 22.7 degrees. So one triangle would have these values, the other triangle would have the 43.1 and these values. So both are viable triangles, and therefore we have to completely solve for both triangles. We have to find all the missing parts for that. So I'm going to organize this a little bit better here for us. So I'm going to let this first triangle have the 65.8 and this second one the 114.2. And then this one's going to have the 22.7 degrees. So in both cases, if we added up these angles here and here, they should add up to 180 degrees. So we're just left with finding side C on both of the triangles here. So we're left with finding side C. Okay, I always again like to go back to what I was given. So in this particular problem, I knew the capital A and the lowercase a, angle A and side A. If I'm going to find lowercase c, the side C, then I'm going to have to use the one that says sine of angle C divided by side C. So if I fill this in for the first case, so we'll just let this be the first case or the first triangle, I'm going to have the sine of 43.1 degrees over the 186.2. All of that I was given to begin with. Here, if I'm going to use, I'm going to use the first angle C here, the 71.1. Over C. So I'm going to cross multiply. So usually once you get these set up, they solve in a very similar way by cross multiplying. Okay, we're going to divide away this sine of 43.1. All right, so we'll put all of this in our calculator, and when we do, we're going to get 257.82 as the length of side C. So I'm going to go back and put that in here. So this is going to be 257.82. So we've now finished this triangle. We just have to go and finish this other triangle here. We're going to do this in exactly the same way. We're going to use the sine of A over A equals the sine of C over C. The difference is going to be that instead of using this angle C, we're going to use the other angle C. So if you'll give me just a minute to get this copied. So our other angle C was 22.7. Right, and then we're going to solve this the same way, cross multiply. Divide by the sine of 43.1. And so we'll get C equals, when we put all this in the calculator, put all that in the calculator, we're going to have 105.16 as the length of side C for the second triangle. So I'm going to go back and fill that in here, 105.16. So just to kind of summarize this, in order to use law of sines, you're going to have to know both values for a particular letter. Once you have that, the ambiguous case is going to be the side angle case. That's the one that you really have to worry about whether you have one, two, or no triangles. So so from there you'll find the first angle, and you'll look and find your first and second quadrants for both of those. Then go on and find the third angle and make sure that that triangle exists. Because if you remember back, I'm going to go back a few slides here. If you remember back here, what happened was once we came up with our two angles that were possibilities, and we subtracted from 180 the angles that we already knew to find the third angle, we ran out of angles. We had already had too much angle to make another triangle. So if you don't have that other triangle formed, you don't have to go ahead and find all the values for that. Okay, but here we did have everything. I'm going to get back to where we were. Okay, so here it did turn out that when we took the two possible angle B's and found the corresponding angle C's for that, that we did have enough left to make a second triangle, and we could go ahead and develop those triangles there. So really the second case, the one where you have the possibility of two triangles, is the most difficult and most time consuming to work through. Okay, on this example, we have another one that has the side, side, and angle provided for us. So side, side, angle is always going to be this ambiguous case that we have to decide whether it's 0, 1, or 2 possible triangles. So if we look at this one here, we have both pieces of information provided for A, so we probably need to go ahead and find the angle B. So I'm going to set this up and do sine of A over side A equals the sine of B over side B. Okay, we'll cross multiply. We need to get rid of this 70, so I'm going to divide by that. So we'll have sine of B equals, and I'm going to, at this point, I'm going to go ahead and put this in the calculator. When I put that in the calculator, I get 1.166. So B is going to be the inverse sine of 1.166. But what happens is, because I can't put a value larger than 1 in here and take the inverse sine of it, I get no solution, or I get an error when I put that in the calculator. So this is why this is the no triangle case. Okay. So to summarize with this side angle situation, if you get a case where you're taking the inverse sine of a number larger than 1, that's going to give you no solution, and you're going to have no triangle for that particular one. The other two cases, you have to just kind of see whether you have what it's going to take to develop into a triangle or not with that. Okay, last example here. A satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles that are 340 miles apart. At an instant when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix and 75 at Los Angeles. How far is the satellite from Los Angeles? Okay, so if we're looking at this situation here, okay, here's our satellite. We've got Los Angeles and Phoenix, and we've got these two angle of elevations. So the question was, how far is the satellite from Los Angeles? So that means we need to find this B here. So we have angle A is 75 degrees, angle B is 60 degrees, and we don't know angle C. Side A, we don't know. Side B, we don't know. And side C is 340. Okay. So if I look at this, what I see is that I don't really have all the pieces for one of the letters, but I also know I could easily find angle C. So if I add these up and subtract from 180, so angle C is going to be 180 minus 75 minus 60. So I'm going to get 45 degrees for angle C. So now I can go ahead and find these others. I don't really need A since that's not answering the question. B is what's answering the question. So I'm going to do the sine of angle B, which is 60, divided by side B, and the sine, since I have both pieces for the C's, I'm going to do the sine of 45 divided by the side C, which is 340. I'll cross multiply divide by the sine of 45. So B is going to be, I'll put that in the calculator. We're going to get 416.4. So we're going to say that the distance of the satellite from Los Angeles is approximately 416 miles. One thing, looking back at how we set this up, this one, both of these could be gotten from the unit circle, but because this was an application problem, we were going to need to report our answer in terms of miles so that people could understand. I mean, we wouldn't necessarily want to report the number of miles as like something on the square root of 2. So we want to go ahead and convert that using our calculator and give our answer rounded appropriately. Okay, so that takes us to the end of the law of sines. So just be, look for those cases, look for your ambiguous case. Be sure that you check to make sure that you don't have the two triangle case because that's the one that seems to get overlooked sometimes. So be really careful with that on your homework. And if you have any questions, let me know, and I'll be seeing you during the Zoom sessions. And hope you have a good day.